Okay, good evening, everybody, and welcome to the last online review session in organic chemistry for the spring 2013 semester. In today's session, we are going to review for the final exam that is scheduled for May the 2nd, and also we are going to review for the ACS exam that is also scheduled for April 30. So for this review session, we are going to use a previous final exam. I do notice that a lot of you have joined us. Just a form of curiosity on my part, I would like to know where some of you have joined the session tonight from. I do see here, Makimba, can you turn your mic on? And let us know where are you joining the session from tonight.
I'm in my dorm right now in Cook.
Oh, okay. You are in the dormitory right now?
Yes.
Okay, so I bet you have been preparing for all kind of exams for this coming week. Is that correct?
Definitely.
Not really. Okay. But Natalia, where are you joining us from today?
I'm home, Professor.
Oh, you're at home? Okay, very good, very good. So you also have been studying for all kind of exams too, huh?
Absolutely.
Okay. Nia Johnson, where are you joining us tonight from?
As well, Professor.
Recognize the rest of you. I do see here a lot of people have joined us. I see Abra G4, Christopher Robinson, Don Payne, Ines Kifando, Maclean Basaki, Natalia Stepanova, Nia Johnson, Oyinolu Sheye, Pravin Chika, Rita has also joined us. We have Shine Aline, and I believe that is all so far. You are all welcome. So right away, we do have a lot of material to cover today. So what I want to do now, I am going to call on can you go ahead and read the first question for us?
Propene reacts with hydrogen chloride to give mainly 1 chloropropane, 2 chloropropane, 3 1,1-dichloropropane, 4 2,2-dichloropropane, and 5 1,1,2,2-tetrachloropropane.
Thank you, and very good. Okay, so what this question is testing here, several things that the question is testing. It is testing your knowledge of nomenclature. It is also testing your knowledge of reaction mechanism. So what is it saying here? It says propene. You have propene. Reacting with hydrogen chloride. And then they are asking you what will be the product of this reaction. So let me ask you this here. In terms of the reaction mechanism, in terms of the regiospecificity of this reaction, is this a Markovnikov addition reaction or anti-Markovnikov addition? Is it okay, very good, excellent. It's a Markovnikov addition. Okay, so if it is Markovnikov addition, let me go ahead and number this carbon here. 1, 2, and 3. So where do you expect the hydrogen to go in terms of addition? What carbon will the hydrogen go to? Okay, carbon number 1. Excellent. So therefore, that is correct because it is a Markovnikov addition. Hydrogen goes to the carbon that contains more hydrogen atom. So you expect to get this product here. So you have addition of hydrogen chloride. Hydrogen goes to carbon number 1 and chlorine goes to carbon number 2. And so what will be the answer to this here? 2 is the answer. Okay. In essay 2 is the answer. That is correct. That is 2-chloropropane. That would be the answer. Excellent. Okay. So let us go to the next one. Okay. Natalia, can you go ahead and read this question for us?
From the reaction sequence, what would be the expected major product?
Okay, thank you. Okay, so what they have given you here, they have given you this reaction sequence, which is this here. And now they want you to give the expected product. Okay, as you can see here, C6H5, that is a benzene structure. In other words, you do have this C6H5, so you have this. Okay, you have that. Then you have bromine in the presence of iron 3. Now, what do you think the product of this will be? What do you expect this product to be? Okay, people. Okay, very good. Okay, so you guys are saying electrophilic aromatic substitution reaction. Okay, so you expect to get this. We could also get the autoisomer because the methyl is an auto para director. You could also get this. Okay, then from here, then they use potassium permanganate. There they say sodium hydroxide. Actually, in reality, it should be dilute acid, but that is fine. Okay, so what do you expect to happen here? What do you expect to happen here? Potassium permanganate, okay. Convert to carboxylic acid. Excellent. Convert the methyl to carboxyl group. Okay, that is correct. So you expect to get this. Okay, that is after the acidification, we get the carboxylic acid plus this here. And also you could, if we use the auto product here, we also get this. Hopefully this is review for all of you. Sorry, bromine here. Take this out. Okay, then from here, you then do nitric acid in the presence of sulfuric acid. And what do you expect to get here? Let me ask you this. Which will be the director here? Okay, which will be the director? The bromine or the carboxyl group? The bromine, because the bromine is a better director. Very good. And it will direct to the auto position. Okay, so therefore we expect to get this.
Why is it bromine?
Where?
Why is that bromine?
Okay, because the bromine, the carboxyl group is a strong deactivator, whereas the bromine is a mild the activator. Okay? Mild the activator, whereas that's bromine, whereas the carboxyl group is a strong deactivator. So therefore, this reaction will be directed by the bromine. Okay? Okay, so now you expect here, bromine is still here, and this reagent here is will introduce the nitro to the benzene molecule. So you have this. Okay, so now let us see what do we have here. Based on what we've done here, what is the answer to this? You have all of these choices here. What is the answer? What is the answer? Based on the choices, okay, number 4, exactly. Number 4, right here. Number 4. So the answer here is number 4. So the question, this question here is testing your knowledge of the reagents. It is also testing your knowledge of the reactivity of a substituent on the benzene molecule. Okay? Okay, so let us go to the next one. Okay, let us see here. Makimba, can you go ahead and read this question for us?
As expected would be
Okay, go ahead. Okay. Okay, only go ahead and read this question first.
For the reaction shown below, the product expected would be.
Okay, thank you. Okay, for the reaction below, the product is expected. The product expected will be. Okay, let us see. Somebody has a mic on. Natalia, turn your mic off. Okay. For the reaction shown below, the product expected will be. Okay, so this is the reaction they have shown below. This right here. Okay, let me ask you this. What is the kind of reaction is this? There is a name for this reaction. Okay, Wittig reaction. Excellent. This is a Wittig reaction. Okay? So therefore, what will be the answer here? Okay, we have 1, 2, 3, 4 choices. What will be the answer? Number 4. Excellent, excellent, excellent. Okay, so you say the answer is this right here. Okay? Okay, so let us go to the next one. So as you can see here, in the Wittig reaction, what you do, you replace the carbonyl of a ketone or aldehyde with a carbon-carbon double bond. Essentially, this carbon phosphorus double bond is transferred to replace the carbon-oxygen double bond, which is right here. And that is why you have this product. Okay, so the next one. Okay, Ania Johnson, can you go ahead and read this for us? Ignore the structure here. Start from here. Just say this structure.
This structure is best prepared by reaction of.
Okay, very good. Okay, so this structure is best prepared by the reaction of. Okay, so now they have given you some choices. Once again, in this particular instance, they are testing your knowledge of reaction mechanism and also testing your knowledge of the synthesis of this class of compound. Does anybody know what class of compound is this? What class of compound is this? What class of compound is that? Ether, yes, excellent. That is an ether. So this is an ether because you have oxygen atom bonded to 2 carbon atoms. So that is an ether. Now, so they are testing your knowledge of the synthesis of ether, also testing your knowledge of the mechanism of those synthesis. Now we know that we have a few synthetic methods for the preparation of ethers. Okay, does anybody have an idea what method will be used to prepare this based on the choices they've given you here? Anybody has an idea? Preparation of ether. We don't have too many methods for preparing ether. It's only a couple of them or so. Okay. Yeah, but what would be the name? What would be the name? Okay, what is the name? Williamson ether synthesis. Very good. Williamson ether synthesis. And in the Williamson ether synthesis, you guys have already told us that it is an SN2 reaction. Okay, so therefore, we know what SN2 reaction is. In other words, you need a nucleophile. You also need an electrophile in which a leaving group is attached to a primary carbon or a secondary carbon in order for you to get an SN2 reaction. So which is the correct answer here? You have 4 choices. What is the correct answer? Here you have this substrate here, primary substrate reacting with a nucleophile. Number 1, excellent. Number 1 is correct. This is correct. Because in this case, you have the nucleophile, this phenoxide right here, acting as a nucleophile, and then displacing the bromine on a primary carbon right here. Okay? So that is correct. Let us go to the next one. Okay, now I don't know how many of you have a working mic. If you have not talked to me tonight or talked to us tonight and your mic is working, can you go ahead and read this question for us? Okay. Okay, Natalia, go ahead and read this question for us.
Treatment of a mixture of 3-butane-2-one and diethyl malonate with sodium ethoxide followed by acid gives one of the following.
Okay, so what have they done here is they are treating 3-butene-2-one and diethyl malonate in the presence of sodium ethoxide. They are treating diethyl malonate in the presence of sodium ethoxide with 3-butene-2-one, and now they ask you what will be the product. They have given us 4 choices. Okay, this question here is actually testing not only your knowledge of nomenclature, it is also testing your knowledge of the reaction mechanism. Okay, so let us see here before you answer the question. We have 3-but, we have of course, the malonate. You have ethyl malonate. Once you treat the ethyl malonate with ethoxide, you form the enolate anion right here. And then they are telling us they are going to treat this here with this molecule. Okay? That is 3-butene 2-on, which is this here. Let me go ahead and number this carbon. 1, 2, 3, 4. Let us call the enolate carbon here, carbon number 5. Let us call this 6. The carbonyl carbon of the ester, and then let us call this 7. Okay. Now, we know that the first thing that is going to happen here, okay. Now, what type of reaction do you think is going to happen first? Anybody has an idea? What type of reaction will happen first? Okay, Michael, excellent. There will be a Michael addition. So this here comes here, attacks this, and then this goes here. Okay, folks, in order to save some time, I am not going to give you the complete mechanism here, because they are not asking for mechanism in this particular instance. So we have this. Attached to this, and then we have this here. Then we have this here. And then we have on this, what do we have? We have, and then here we have, okay. Then let me go ahead and number the carbons here. This is carbon 1, 2, 3, 4, and this is our carbon 5 from the malonate. And we say this is 6, and we say this is 7. Okay. Now, at this point, since we have in solution this here, okay, this here, this solvent here, will protonate this here. So let us save ourselves some time and simply take this out of here. So now it will protonate that. Now we have this CH2. Okay, so that will be the initial product. Now, of course, plus you have ethoxide. Now this ethoxide now, what does it do? It comes in here. We pull this one of the hydrogen here, the alpha hydrogen here. If it does that, let me make this easy for you. So we have this here. So now we are going to do this, get this. Now we form enolate here, right? Okay, plus now we have this here. Once this pulls this from here, now what do you think will happen? Now this comes in, attack this. Okay, this will go up here. The carbonyl will go to the pi electron on carbonyl will go to oxygen, and then when we reform the carbonyl, this will leave. The ethoxide will leave. Okay, like I say, I am trying to save some time here. So what do we get? How many ring systems do we have? 1, 2, 3, 4, 5, 6. So we have a 6-member ring system. Okay, and therefore we get this. Okay, so this carbonyl here, if we say we have the carbonyl on carbon number 2, and then we have another carbonyl, since this ethoxide will go, we have a carbonyl also on carbon number 6, okay, and then on carbon number 5 right here, we have this here. Okay, so this will be the product. This will be our product. Okay, so in this particular problem, does require that you know the reaction mechanism. So therefore, what is the answer here? What would be the answer? Okay, you have, okay, number 2. Excellent, excellent. This is not a question that you could just make a guess. You really do need to know the reaction mechanism. The answer to this is this here, which is this molecule right here. Okay? So in this particular instance, it is very helpful that you know the reaction mechanism. Okay, so let us go to the next one. Unless there's a question. Okay, let us see here. I do not know how many of you have a working mic. I see that a lot of people have joined us. I see Spencer Mitchell joined us recently. I see that, let's see, Lorenzo Amon joined us, Lona Kuma joined us, Augustine Adejumo, okay, Don Payne, okay, Ayodotun, okay, very good. Lona, is your mic working? If your mic is working, can you read this for us? Just the reaction of this compound.
Reaction of this compound with aqueous HCl produces.
Okay, thank you. I'm very good. Okay, so now what do we have here? Okay, they say this compound here reacts with aqueous HCl, dilute acid, to give all of these choices here. So let me ask you this before you answer this question. What class of compound is this? What class of compound is this? Anybody has an idea? What class of compound is that? Okay, anybody has an idea? It is protective group. Okay, it is an acetal. Acetal. Okay, it is an acetal. Acetal because anytime you have, it's almost as though you have a double ether, and then this oxygen here, this alkoxy group is attached to a carbon, another alkoxy group attached to the same carbon, and that carbon is attached to an hydrogen atom. In that case, you have an acetal. Now, whenever you have an acetal and you react with dilute acid, what happens? It will break down to give you the corresponding aldehyde plus, in this case, the diol. Okay? Okay, so what would be the answer to this question? Okay, say number 3. Very good, very good. Okay, that is correct. Okay, this question also could apply to, supposing I have this. Yes, number 3 is the answer. That is correct. Supposing I have this. What class of compound is this? What class of compound is this? That would be a ketal. Very good. This would be a ketal. Very good. Okay. Similarly, if I now have dilute acid here, okay, what do you think I will get? If I have dilute acid to this, what will I get? Yes, you get the ketone and then the corresponding diol that was used to make the ketal. This case would be ethylene glycol, which is this here. Ethylene glycol. This is the same solvent that is used in your antifreeze liquid for your car. Okay, so let us go to the next one. So the answer here is number 3. Okay, okay, let's just see here. Makimba, are you back? If you are back, can you go ahead and read this question for us?
reaction of the following with sodium methoxide is expected to give.
Okay, thank you. Okay, so what do they have here? Very good. So what do they have here? The reaction of this compound here, they say with sodium methoxide, is expected to give any one of these products. Okay, so another case in which they expect that you know the reaction mechanism, and let me make things easy for you. This compound here, that would be this here. That is this compound here. Okay. Now, let me go ahead and number this for you also. Let's say this is 1 carbon 1, 2, 3, 4, 5, and 6. Now, what kind of reaction do you think this is going to be? What they have here, what do they have? Ethoxide. Okay, what kind of reaction is this? There is a name for this reaction. Clasing, exactly. This will be an, very good, excellent. This will be an intramolecular clasing condensation. Intramolecular clasing condensation. Generally, we refer to that as Dieckmann. We refer to it as Dieckmann condensation. Dieckmann condensation. Okay. So, let us take a look at it. We now know that this is an intramolecular clasing condensation, which means we need a nucleophilic carbon and then an electrophilic carbon. So which of these carbons here will be your nucleophilic carbon? Which of these will be, just give me the number. Okay, you want to use 5, very good. So what you are telling us here, that this here, you are going to form your nucleophilic carbon right here. You form your enolate ion here. And then you know that once you form your enolate ion, that will simply attack this carbonyl carbon here, because carbon number 1 becomes your electrophilic carbon, attack this right here. And if it does that, how many carbons do we have in the chain? 1 in the ring system. 1, 2, 3, 4, 5. So we are going to have a 5-member ring. We have a 5-member ring system. And if that is the case, so that means on carbon number 5, which is here, we have this here. Okay, carbon number 5 is joined to carbon number 1 right here. So therefore, because once this goes to the carbonyl, the pi electron goes to oxygen, and then once you reform the carbonyl, the ethoxide will leave, so you end up forming this. Okay. So therefore, based on what I've given you here, what is the answer to this? What is the answer? Number 1, exactly. The answer is number 1. It's right here. So once again, this reaction also requires that you know the reaction mechanism, you know the type of reaction, you also know the reaction mechanism. Okay, just memorizing the question will not help you. You do need to know exactly what is happening with regard to the reaction mechanism. Okay, so let us go to the next one. So 1 is the answer right here. Okay, let us see here. If you have not spoken tonight and your mic is working, can you pick up the mic and read this for us? Does anybody? Okay. Okay, Oyin, go ahead and read this for us.
Nucleophilic substitution of the type of this molecule occurs via.
Okay, very good. Okay, what they've done here, thank you. What they've done here is a nucleophilic substitution of the type. In other words, they have given you this reaction. That's what they mean of this type. It's a nucleophilic substitution. It's a nucleophilic acyl substitution reaction. Now, what is going on here? Essentially, the methoxide has replaced the ethoxide. That is what is happening. So it is a nucleophilic acyl substitution reaction. Nucleophilic acyl substitution reaction. Okay. Now they say it occurs via any one of these reactions. They're giving you some choices here. Okay. They're giving you some choices. It occurs via addition of methoxide followed by elimination of ethoxide, or elimination of ethoxide followed by addition of methoxide, or a one-step backside attack by methoxide, or the final choice here, the formation of a carbonium anion pathway. So which would be the correct answer? Number one. So very good. Number one, okay, addition of methoxide followed by elimination. Exactly. Number one is correct. So this is another case of knowing your reaction mechanism. Okay, that is the correct answer, number one. Okay, you have to know the reaction mechanism to answer that question. Okay, let us go to the next one. Okay. Lorna, go ahead and read this for us.
The major products from the reaction of this molecule with excess ethyl magnesium bromide followed by treatment with dilute acid is.
Okay, very good, and thank you. So, what are they giving us here? They have given us an ester. They're giving you an ester here. This molecule. And they say it will react with ethyl magnesium bromide. In other words, they want this to react with a Grignard reagent. So which would be this here? Step 1 and then step 2. Okay, so what is the product? They're giving you 4 choices. What will be the product? Once again, you need to know the reaction mechanism. Okay, all of you say number 4. Okay, number 4 is correct. Okay, folks, you need to know that a Grignard reagent will react with an ester to form a tertiary alcohol. Tertiary alcohol. Sorry about that. A Grignard reagent will react with an ester to form a tertiary alcohol. Anytime you have a Grignard reacting with an ester, you form a tertiary alcohol. And that is what we have here. Look at here. This here is from the Grignard. This here is from the Grignard. It just so happens that this other ethyl group was in the original molecule, which is right here. Okay? That other methyl group, that is right here. Okay? Okay, this is another case of knowing the reaction mechanism. Okay, so keep that in mind. A tertiary alcohol reacts with, an ester reacts with a Grignard reagent to give you a tertiary alcohol. Go to the next one. Okay, let us see here. Natalia, go ahead and read this for us.
The compound below is called one of the...
Thank you. I'm very good. Okay, now they have given you about 5 choices here. So this is a straight case of nomenclature, just knowing your nomenclature. Okay, so they say this compound here is called 3,4-dimethyl 2-pentanol, 2,3-dimethyl 4-pentanol, 3,4,4-trimethyl 2-butanol, 1,1,2-trimethyl 3-butanol, and finally 1,3,4,4 tetramethyl 1-propanol. So what will be the answer here? What is the answer? You say number 1. Someone 1. Let us see. Is that correct? The longest carbon chain. Okay. Let us see. The longest carbon chain, starting from here. This is 1, 2, 3, 4, 5. So that is a pentanol. That is so far so good. And then you have the hydroxy is in 2 positions. That is there. And then the branches are in 3 and 4. 3, 4. Number 1 is correct. That is correct. So this is the correct answer. Okay. So this is just a case of nomenclature. Okay. Next one. Okay. Let us see here. Nia Johnson, can you go ahead and read this for us?
The IUPAC name for this compound is what?
Okay, go ahead now. Continue.
3-bromo-4-hexanone, 1-bromo-propyl ethoxyketone, 2-bromo-butanol ethyl ether, ethyl 2-bromobutanate.
Okay, thank you. So this is another case, very good. So this is another case of nomenclature. So what would be the answer here? Let me ask you this. What class of compound is this? What class of compound is this? What class of compound is this? Okay, let's see here. Ester, very good. This is an ester. Okay, this is an ester. So therefore, that means this one is out. This one is out. This this one is out, right? All those choices are out. So the only ester here is this. That is therefore the answer is number 4. The answer is number 4. Okay, it is an ethyl 2-bromobutanoate. Ethyl 2-bromobutanoate. Okay, so therefore you have the longest carbon chain. That is 1, 2, 3, 4. So it is the ester of butanoic acid, and of course you have the ethyl group right here. So it becomes ethyl, and the bromine is in 2 positions, becomes 2-bromobutanoate. Very good. So this is the correct answer. Okay, let us see here. Makimba, can you go ahead and read this for us?
Which compound is most acidic?
Okay, very good, and thank you. So which compound is the most acidic? We shouldn't have to spend too much time on this. So which would be the answer here? Anybody? Which would be the answer here? The compound is being most acidic. Being most acidic. Which one is most acidic? In other words, which one gives you the most stable conjugate base? Most stable conjugate base? Which of these will give you the most stable conjugate base? Okay. Keep on going. Which will give you what stabilizes the conjugate base? What will stabilize your conjugate base? Okay. Okay, now, no, the answer is 3. Okay? The answer is 3. Keep in mind, this is what we said. When you talk about acidity, you are really talking about the stability of the conjugate base. In other words, the conjugate base is that ion that will form after you remove the hydrogen, the proton. So if we remove the proton from here, what do we get? We get this. We already have this here, right? So we do that. So we form, okay, so we form this conjugate base right here. Now this conjugate base can be stabilized by 2-carbonyl using resonance. Okay? So I could use resonance to stabilize this. This could move to here, pi, that the electron, this pair of electron moves here to form a pi bond. And therefore this goes to here. So what do I get? I get stabilization due to resonance. Okay. And then I could also get another stabilization on this carbonyl. So there are 2 possibilities for stabilizing this conjugate base. Okay, it goes here. Okay. Okay. On the other hand, if you look at these other molecules here, even if you form the conjugate base of any one of them, you cannot get stabilization in as much as you have in this particular case of number 3, because you are able to stabilize the conjugate base as a result of resonance due to the contribution from this carbonyl and also this carbonyl. Okay, so that is why this is the most acidic. Okay. Okay, let us now go to the next one. Okay. Okay, I am running out of names to call here. Let us see. If your mic is working and I have not talked to you tonight, can you pick up the mic and read this for us? I want all of you to be part of this session tonight. Okay.
Which method cannot be used to produce the following?
Okay, thank you. Okay, that's Spencer Mitchell. Okay, you are welcome. That is the first time I hear your voice tonight. Very good. Okay, so what are they telling us here? Say which method could not be used to produce the amine, this amine right here? Okay, which of these methods could not be used to produce this amine? Okay, this is a primary amine. Notice this is a primary amine. Okay, let us look at the first one. Okay, anybody has an idea? What would be the answer here? Okay, say number 3. No, okay, very good. Number 3, that is correct. Number 3, because if you take number 3 and you react with lithium aluminum hydride, this is what you get. You could almost do this by elimination. If you do number 3, this is what you get. In number 3, what you do, you are reducing a cyanide to a primary amine. This is what you get, and that is not this compound. That is not this compound. Therefore, the answer is number 3. Number 3 cannot be used to make this compound. Okay, if you look at number number 1, you could use number 1 to do it. That would be an SN2 reaction. You could use number 2. This would be a Hofmann elimination for number 2. And of course, number 4 will be reductive amination. And with the reductive amination, you could form this molecule here. Okay, so all of those methods could be used except for number 3. The answer here is number 3. You cannot use number 3. Okay? Okay, so let me go back to my original list of names here. Only go ahead and read this first.
Which compound gives this molecule on ozonolysis?
Okay, thank you. Very good. Okay, so here, once again, they are testing your knowledge of the reagents. It says, which of these compounds here, compound 1, 2, 3, and 4, will give this here upon ozonolysis? Upon ozonolysis. If you take a look at this here, this is a methyl ketone. It is also an aldehyde. So what will be the answer? The question is, what does ozonolysis do? I guess that is what they are trying to find out here. What does ozonolysis do? Okay, cleaves a double bond, exactly. Cleaves a double bond to give ketone or aldehyde. Okay, so what do you say the answer is? You guys say number 2. Number 2 is correct. Number 2 is correct. Excellent. Okay, because if you clip this right here, okay, on this carbon here, let me go ahead and number those carbons. Okay, we say this is 1, 2, 3, 4, 5, and 6. Okay, if you clip this, carbon number 2 becomes a carbonyl of the ketone, and carbon number 6 becomes the carbonyl of an aldehyde, and that is what you get here. So the answer here is number 2. Okay, go to the next one. Okay, we are moving right along. Okay, we have about 7 more minutes to 9 o'clock. Okay, now, let us see here. Nia, go ahead, can you go ahead and read this for us?
What is the major product of the reaction given below?
Okay, very good, and thank you. Okay, so what they are essentially asking, this is a straightforward electrophilic aromatic substitution reaction, which they say, what is the major product of this reaction? This is the reaction right here. What is the major product? So what they are also testing here, your knowledge of the directive activating activity of different groups. No, let me look at this here. Let us call this part of the molecule, let us say this ring, let us call this ring A, okay? And let us call this ring B, okay? Now, we know that on ring A, you have a methoxy group that is attached, and on ring B, you have a nitro group. Okay, which of this group here is an activator, and which is a deactivator? Which is the activator and which is the deactivator? Okay, methoxy, very good. So therefore, if the very good, that is a good answer, by the way. So if the methoxy is the activator, where do you expect this reaction to occur? On ring A or ring B?
Oh, for Mathematicus?
On ring A or ring B?
Oh.
Spencer, can you turn your mic off? Spencer, turn your mic off. Okay, very good. Okay, so therefore, where would it be? The reaction would be on ring A or ring B. Ring A, okay, because the activator is on ring A. Okay, therefore, so what would be the product? We know that this methoxy group is an autoparadirector, so therefore the product will be, what would be the answer here? What would be the answer? Answer is number 3. That is correct. Answer is number 3. Somebody have their mic on. Can you turn your mic off? Okay. Okay. Okay, now, so the answer is number 3. Okay? Because in this case, the methoxy will be the director, will direct to ring A, and of course, this reagent here, what this reagent does, this is for nitration. Okay, this reagent introduces a nitro group to the benzene molecule. Okay, very good. Okay, now let us see here. Natalia, can you go ahead and read this for us?
To convert aniline to benzonitrile, which sequence would be acceptable?
Okay, very good. And thank you. So what they are asking you to do here, they want you to go from aniline, so you need to know your nomenclature also here, and also you need to have a knowledge of those reagents. You go from aniline to benzonitrile. That is benzonitrile. Okay. Now they say, what sequence are you going to use? What sequence are you going to use? Okay. Notice what are we doing here? Going from an amine, a primary aromatic amine, to a nitrile. How do you introduce a nitrile to the benzene structure? Okay, diazonium ion, we are going to do diazotization. Excellent. Excellent. We said that. That's our Ines. Very good. Diazotization. In other words, you are going to convert this to, just for the benefit of those of you to refresh your memory, use nitrous acid in the presence of sulfuric acid to form your diazonium ion. And once you form your diazonium ion, and then you introduce KCN, and in the presence of copper cyanide, okay, then you get this here. Okay, so what will be the answer here? What is the answer? Number, did you say treat aniline with nitrous acid? No, you need copper cyanide. You need copper cyanide. Okay, treat aniline with nitrous acid, and then with, yes, number 3 is the answer. Okay, the copper must be there. Copper must be there. And this is what we call the Sand-Meyer reaction. the copper must be there. Okay. Okay, so you treat the aniline with nitrous acid, which is what we did to form your diazonium ion, and then subsequently you treat with copper cyanide in the presence of, in this case, potassium cyanide. Okay. Okay, let us see here. Lorna, can you go ahead and read this for us to the best of your ability?
The isolated product of the reaction is...
Very good, thank you. Okay, so this is another case of testing your knowledge of the reagent. Okay, so you have a reaction between acetone and hydroxylamine. Okay, okay, so this is just a case of the amino group on this here. The amino group will be acting as a nucleophilic agent. Okay, so what will be the product here? What is the product? Anybody? Number 2, exactly. Number 2. Okay, this will react the same way that you have, if, for example, if you have a ketone reacting with a primary amine, you form an amine, you form this. This is called an amine. An amine. Okay, so the same way, if you have the same type of reaction, so therefore, if you have hydroxylamine, okay, just think of the hydroxy group as an R group. You're also going to form this. An amine type molecule. The difference now, you are going to have the hydroxide instead of the R group. We call this an oxime. Instead of calling this an amine, we call this an oxime. Okay? Okay, so that is the answer is number 2. And that is what you have right here. Okay, let us move. Okay, keep on moving here. Okay, let us see here. Okay, Nia, can you go ahead and read this for us?
On mononitration, which compound will yield the highest para-ortho ratio?
Okay, very good. I believe we did this in one of those sessions that we did in preparing for, I believe, exam number 2. Anyway, the answer here, okay, the answer here is number 4. Okay, I'll tell you why. Okay, on mononitration. Okay, so what are the choices you have here? You have toluene, number 1. This is toluene right here. That is toluene. Then you have number 2, ethylbenzene. This is ethylbenzene. Then you have isopropylbenzene. Then finally, this is isopropyl. Then finally, you have the tertiary butylbenzene. if you look at all of this, this is tertiary butylbenzene. All of these choices here, look at this here. Because of steric hindrance, or what you might refer to as bulkiness, okay, when you want to react this, keep in mind each one of these reactions here, you are going to perform nitration. You are using nitric acid. Now, if you use this here, the product you are going to get will be this. If you use the tertiary butylbenzene, you are going to get this almost exclusively because this branch here is so bulky, it directs all incoming group to the para position. It is a auto-para director. However, because it is so bulky, it directs almost exclusively to the para position. So that is why you are going to get this. You will not get too much of the auto product. And the question they are asking is, which one of these will give the highest para to auto ratio? So the answer is number 4, because this will give the most para product. The rest of them will give some auto products because they are not as bulky. The groups are not as bulky as the tertiary butyl group. Okay? Okay, so let us go to the next one. Okay. Let us see now. Okay, so Natalia, go ahead and read this for us.
Which reagent causes skeletal rearrangement in the reaction of the following?
Okay, very good. Okay, after we do this question here, I would like us, because we have spent 1 hour already, and if we go way beyond 1 hour, it will be very difficult to process the file. The file will be so large. So if you guys do not mind, after this question we stop, and then any one of you who would like to come back in 30 minutes, everybody should log out, and then in 30 minutes we'll come back again, and then we could continue from question number 20. For those of you who would like to do that, okay, because if I stay any longer, it will be very difficult to process the file. Okay. Okay, so now, the question is, which reagent causes skeletal rearrangement in the reaction of this here? So, which reagent? You need to know the reaction mechanism here. In other words, they are asking you which of this reaction here, if it reacts with this molecule, will give a carbocation. That's what they are asking you. Okay, so the molecule that we have is this here. Okay, which of these reagents here will give a carbocation when it reacts with this molecule? That is essentially what they are asking. So what would be the answer here? What would be the answer? Okay, you have, okay, I will tell you right away to save some time here. You are going to get number 4, because number 4 is an acid to protonate the carbon-carbon double bond. Once you protonate the carbon-carbon double bond, you get this. It is, of course, a Markovnikov addition. So you get that. And this carbocation, this is a secondary carbocation, and this will rearrange very easily as a result of alkyl shift to a tertiary carbocation. So this reaction here is actually asking you whether you know the mechanism of addition to a carbon-carbon double bond. So now you form a tertiary carbocation. So anyway, at this point, let us just log off for right now. All of you should log off, and then give me about 30 minutes. Come back in 30 minutes, then we are going to continue from question number 20. Okay? So see you in a few minutes.